pie graphs today, okay? But representing data graphically. I am going to use the book a lot because there's a lot of data in here that I just need to write up for you, and then we're going to talk about how we're going to do this. What is a line plot exactly? Does anyone remember? Yes?
Is a line plot when you plot things on the line?
So, sort of, like where I make X's above it. If it's,
That is a great answer,
Good,
Tyler.
Tyler. So yes. So if I have like test scores, we're gonna do test scores here in just a second. You guys said ooh. Ooh. So let's talk.
Are we going single digits here?
Let's talk test scores. Okay. So hey, this is the time where you close your mouth and you listen. Okay? The less you talk, the quicker we get done with this. Let's try to get done with it within 13 minutes. Let's do this.
That's precise.
You just do like a 15 or something. I don't
Okay,
like
15, Cameron. Let's try to get done in 15. Okay. So this problem says the scores from an economics class of 30 students are listed. The scores are for a 100-point exam. You have the scores of 93, 70, 76, 67, 86, all this stuff. 93, 82, 78, 83, 86, 64, 78, 76, 66, 83, 83. 96, 74, 69, 76, 64, 74, 79, 76, 88, 76, 81, 82, 74, and 70. Okay? If I'm making a line plot, what do I have to do with that data? I just put a dot or an X above each number that's represented, okay?
Yes.
So if I start with 93, that's like right about here, right? Okay? And then it had 70, and then they had 76. And then they had 67. You get what I'm doing here, yes? Okay. And then they had 86. And then they had 93 and 82. 93, 82.
Another 93?
Yep, another 93. Then they had 78 and 83. 78, 83. Okay? So we're just going to mark this, and we're going to keep putting tally marks wherever they go. We'll have 30 total X's when we're done with it, yes? That's right. Okay? That is a line plot. Then they want to know which score occurs with the greatest frequency. How would I be able to tell that once I plot everything?
Line up all
How
the
many are
numbers.
on
Or you could just
So right now, if we just go off of this data, which one has the most frequency?
the 93.
The 93, because there's 2 there. So you're just going to make a line plot, you're going to put X's or dots, and then you're reading which one has the most. Okay? You can handle that. What is the range? How do you find range of data again?
You add the
Oh, you
Don't you have the
highest and the lowest.
Good, yes. Take the highest number, lowest number, and subtract. That's range. What you're thinking about is median.
I thought that was me.
Oh,
I'm thinking about.
yeah.
Oh, we talked about
So, yes. So range, I take the highest number, the lowest number, I subtract. That's all we're going to have to do for line plots tonight. Those 3 things. You're going to have to find the frequency, you're going to have to line plot it, and you're going to have to give me the range. Can you handle those 3 things?
Yes.
Frequency is which one happens the most often. Kind of like the mode and frequency are the same. Okay? So line plots should be simple for you. You should be able to handle that. You did it when you were in 1st grade. Okay? You probably started in 3rd grade, but yes. Okay. On page 58, they talk about histograms, and the reason I'm directing you to that page is because there's a lot of data we need to look at there. So on page 58, they talk about histograms. What is a histogram? How can you tell what a histogram is?
a graph of history.
It's not a graph of history. It looks like a chart, but there's a difference between histograms and bar graphs. What's the difference?
Oh, wait. This way. This way. Yeah,
No, the
like that.
bars is.
I didn't take anyone out. Okay.
No, not necessarily. Okay, listen. Histogram and bar graphs. They are both
There's no gap.
right. In histograms, there's no gaps with what you're graphing. In bar graphs, there's a gap between each set of data. What's the point? Okay? Because histograms are usually a range of data. So like, for the example they give you, they take all 50 states and they tell you the population of all 50 states. Okay, now is any state going to repeat the population probably?
No.
No, so you're going to set up your histogram like this. You would set it up with a range, like down here would be between 14 and 18 million, something like that, okay? And then you would do something like between 19 and whatever, so you would keep all of your data broken up into the same intervals, okay?
This can't be right.
What can't be right?
It says California only has 12.1, while Florida has 18.2.
And is this in millions or billions? Probably millions.
And when was this book published?
It was,
Right.
it says-
In the world.
This book was published in 2012, 13, so it's not like,
Well, it's not outdated, so not.
it's not super
It's
outdated,
accurate-ish.
okay, it's pretty close. So what they show us here is that, I think Arkansas has the least with 8.5, yes?
Let me see. Yeah,
And then the greatest is what, 17? Is that what I'm seeing as the great, no, Florida?
They are.
Florida has 18.2.
Okay, Florida has 18.2. So if our least is 8, okay, and our greatest is like 18.2, okay? We've gotta figure out what our segments are going to be, okay? So between 8 and 18.2, for some reason, they go between 20 because they're gonna do it this way. If I go 8 through 10 as an interval, okay? And the way they write their intervals are interesting. So it's going to include 8 and then it's gonna have like a parenthesis around 10. Because when you do intervals, notation like this on histograms, the next set of data would be from 10 to 12. Okay, you're always gonna have that second number repeat. Because this is where it includes 8 and goes to 10, this includes 10 and goes to 12. So then the next one includes 12 and goes to 14. And you wanna keep this same range of numbers, okay? So like, there's 2 in here, 2 in here, 2 in here. So then I would have 14 to 16, right? And then I would have 16 to 18, and then I would have 18 to 20, because I have to do anything over 18, and we had 18.8, right? And so then, those,
18.2.
It's still.
or 18.2, is that what you said?
Yeah.
So then this one represents, if I were to graph this on the bottom, okay, first we have to tally up everything, like what fits in between these intervals. So if I go through the data, I have 8.5 for Arkansas, and then I should have 9.5 for Utah, so there's only 2 that fit under here. So you're gonna make tally charts first, under each of your intervals, does that make sense?
Also, for which state
Yeah.
has the number between
Between
whatever?
that, no, yeah.
Okay.
And then the next one, the 10 to 12, there are 4 states, they already have it tallied up for me, so. And then the next one, there are 15 states, and then 26, is that what you said?
Yep.
Yeah, it's gonna. It was.
And then 26, and then 3, and then there should be 1, right? Because it's only 18.2. So then from there, I can now set up my data. So this would be 8, this would be 10, 12, because I'm gonna go by what I'm counting by here. 14, 16, 18, and 20, okay? For my histogram. Now, going up, I can count by whatever I want, but since we're doing millions of people, right? Is that what it is? Population, well, the bottom is the percent of population. The other is number of states. And the reason these numbers seem weird and only 18.2, Alex, is because it's the population of 65 and
No
older
wonder why there's so many old people
in Florida. So this is population,
That's why they all flock.
65 and older, okay? And then this side is my number of states, okay? And the greatest number of states we have over here is 26, right? So we're gonna count by 5, it'll be easy.
Yeah, Jason.
What is your smallest cell? What is?
Okay, and then for histograms, I'm gonna come here and between 8 and 10, I only have 2. So I come and make my little histogram like this. And remember, you must color it in. Okay, so I go to 2 and I color it in. Between 10 and 12, I have 4. And this is where they stay together. They should touch. Okay, then I have 15. So here, okay, I'm going to shade that in, and I would keep going. Does that make sense how to do a histogram? Okay, so you're going to tally, you're going to figure out what your intervals are first, then you're going to tally it up, then you're going to graph it and color it in, and they touch. Okay, bar graphs are what you're most used to, correct? Probably, that's my guess. Okay, bar graphs, they give you 2 really easy examples. The table shows the number of Walmart stores from 2008 through 2013. Construct a bar graph for the data, and what can you conclude? So it gives us data from 2008 to 2013. So if I'm doing a bar graph of the data, I'm going to have 2008, 2009, 10, 11, 12, 13, yes? Okay, and then it tells me the number of people, right? Number of Walmart stores, the number of stores. So the first one is 70, the lowest is 7,720. The highest is 10,942. So I need to count by 2s and go to 12,000. Okay, now listen. Do you see on my bar graph how I have this little thing here?
I don't know who to show you.
Why do I have that? Why is it a broken bar
Yeah, I
graph?
don't know. I was about to ask you that. That's kind of confusing.
Good. Okay, so a broken bar graph allows me, when I do that, it shows that it's a broken bar graph, meaning this down here is not 0, 0. So it lets me see the data closer up, okay? Because I'm breaking the graph and meeting where they would actually start the data at,
I ain't gonna have a broken bone, right?
okay? That's what it
How you
means.
gonna have an imaginary number?
Now in 2000,
Exactly. You can't make up numbers.
in 2008, they had 7,720. So it would be someplace in here, and I'm gonna make this bar graph like this, right? Color it in. And then in 2009, the only difference between this is that I do not connect them. So it's 8,400. So it's something like this. Okay, so do not connect them. There should be gaps in between them. Oh, Lord. That back table is going to have fun on their homework since they're not paying attention.
Ooh, she called it out.
We're stretching.
Or, you know, they might just not give it to me like normal.
Ooh.
Whoa. Who ain't giving in their homework? Cause I know Tally is. Excuse me.
Okay, double bar graphs. Double bar graphs are when I have 2 sets of data at the same time, such as I take data for the boys in the class and the girls in the class. Okay? And when you're doing double bar graphs, often they're going to go sideways, like this. So if I had like boys data here and girls data here, and it was number of girls that played sports or something, it would go like this, and then the boys would be like this. And they don't touch either. But it's so that you can compare 2 sets of data next to each other. So you only have the double graph when you're comparing 2 sets of data next to each other. Does that make sense?
See.
Okay? But it's constructed the same way as a bar graph. What's a line graph?
A graph with a line.
You plot points and then you play connect the dots. Okay? You plot the points and you click connect the dots. So constructing a constructing a line graph, you can do on your calculator like we did last time by putting in the data to your X and Y and having them plot the boxes. Okay? And then you can just make a rough sketch of that data and connect it for me. That's fine.
I kind of like that.
Because they're not going to be perfect lines on your homework tonight because it's going to be like, you know, this store made so much money in this year, and then in this year this money, and then this year. So it can go up and down. Okay? So line graphs should be easy. That is what your homework is on tonight. It's all data stuff.
Word.
Okay?
So can we have not a lot amount?
Yeah, I'll just give you like 1 or 2 of each.
That's great.